Well, welcome everybody, all the fellows of the British Pharmacological Society. It's a real pleasure to be here with you all this evening. It's one of the nice traditions that we've just started, and I hope will go on for a long time, to have this gathering of distinguished fellows of the British Pharmacological Society. It's a really nice occasion. So welcome to you all, and I hope you all enjoy yourselves. My first task this evening is to announce the winners of our Hall of Fame, Pharmacology Hall of Fame competition. There were a number of names put in the list, and by vote among all the members of the British Pharmacological Society, the following names, which I'll say a little bit more about in a moment, have been elected to this group. This again was a tradition started last year when we elected 5 distinguished individuals to this, and here are the next 5. The first one is Professor Bill Bowman from Strathclyde, whom I think most of us in this room will remember and value as a personal friend. He trained in pharmacology at the School of Pharmacy, did his PhD in Oxford, and quite soon moved to Strathclyde, and he set up the first department of pharmacology in Strathclyde in 1966, so that's nearly 50 years ago. He was well known partly as an extremely enthusiastic member of the society who was a delight to talk to about any subject under the sun. He was a great raconteur and a really funny man when he chose to be, and a very serious man when he didn't choose to be funny. And his research over the years was really focused on neuromuscular transmission and the action of neuromuscular blocking drugs. He was the first, I think, to demonstrate pharmacologically that curare, tubercurin, acts not only at the postsynaptic membrane but also has important presynaptic effects on acetylcholine release. And he produced a long series of papers on neuromuscular transmission and neuromuscular blocking drugs. He was also, with his good friend and co-author Mike Rand, the author of Bowman and Rand's textbook of pharmacology, which certainly I, as a student, used to use as a source, and even more importantly, when I started having responsibilities for teaching pharmacology, it was the text I went to get my ideas on the subject straight. So he really deserves a lot of recognition for having done that. He was also interested in clinical applications of drugs, and was a key member of the group that developed neuromuscular blocking agents, particularly vecuronium, which is now very widely used clinically. So he's a very significant member of our Hall of Fame. He died, sadly, I think in 2010, but I think nearly all of us will remember him. The second on the list is Sir Derek Dunlop, who was trained in medicine in Edinburgh, and in fact was a professor of medicine and therapeutics in Edinburgh for many years. He was one of the first people to get seriously involved in regulatory affairs relating to the safety of medicines. And I'm sure you'll recall, following the thalidomide tragedy in the early 60s, the whole process of regulation of medicines with a focus on safety really became a huge priority for the world at large, and was represented in this country by the Committee on the Safety of Medicines, which Dunlop was the first person to chair, and he went on to chair the successor organisations in this country related to the safety of medicine. So he's been a huge contributor to regulatory affairs in this country. He was also a very distinguished physician. He was actually physician to the Queen in Scotland, so no doubt when she went to Balmoral, when she needed something, she would phone up Derek Dunlop for assistance. So he too is a very significant figure. By all accounts, I never knew him, but by all accounts he was a delightful man and very willing and enthusiastic in his teaching responsibilities, as well as being a first-class clinician. So in the field of clinical pharmacology, he certainly stands very highly in our esteem. The third member on this list is Professor Hans Kosterlitz, whom I think nearly all of us will remember very well. He too was an extremely active person within the British Pharmacological Society, well known of course for his work on opiates and opiate receptors, which received very wide recognition. Interestingly, he only really began to take a serious interest in this field in the mid-50s, when he was already quite an old man. He was born, in fact, I've got it here, he was born in 1903 in Germany, so he was already really a well-established pharmacologist before he got going on the field that really propelled him to international fame. He again, I think it's true of all these individuals that I'm talking about this evening, he was a delightful man and a good friend to many of us. Extremely approachable, enthusiastic, interesting, and in his way rather humble. He was certainly not an individual to promote himself, but he had a passionate interest in the field of pharmacology on which he worked, which prevailed for many years. And it was a long time, really, during the time that he first got interested in opiate mechanisms to the time that he made the breakthrough with the discovery of enkephalins. This was 20 years or more, where he worked steadily along in this field, doing excellent work, but not really making the breakthrough that later propelled him to fame. So he again is a very welcome addition to our Hall of Fame. I should have mentioned that he was the first professor of pharmacology at the University of Aberdeen, where he stayed for most of his years, and in fact they only promoted him to a professorship. They didn't have a professor at all, and they only promoted him to a professorship after he'd been there for some 20 years or so. So it took a little while for the penny to drop in the University of Aberdeen, what a star they had in their midst. The fourth name on this list is one close to my heart, certainly. That is Heinz Schilt. Heinz Schilt, as you'll know, was Professor of Pharmacology at University College London for most of his career. He, like Hans Kosterlitz, came to this country in the 30s as a refugee from Nazi Germany. And Heinz Schilt was actually interned on the Isle of Man as an enemy alien for some years. And eventually, I think representations from Henry Dale and others to the Ministry of Defence allowed him to be freed and to get back to work. Well, I say he's close to my heart because he was the person who taught me pharmacology in my early days as a student at University College, and I got to know him extremely well. What was impressive about Heinz Schult was really the breadth of his knowledge and the breadth of his interests. He really first gained fame through his work on anaphylaxis and histamine release. Anaphylaxis had been worked on by Henry Dale and others, and histamine also, but it was really Heinz Schult who worked out the mechanisms by which antigen-antibody reactions on the surface of mast cells actually evoke histamine release and many of the phenomena of anaphylaxis. He, as I'm sure you'll know, was very interested in the analysis of drug-receptor interactions using the law of mass action, really following on from the work of Gadam and Clark and others, applying the law of mass action. But it was Schult in particular who applied it very successfully and rigorously to the analysis of competitive antagonists acting on receptors, and he described the dose ratio plot, which everybody now recognizes as the Schult plot, as a way of classifying receptors and antagonists, which has become, still is really, a key approach to new drug discovery. Jim Black certainly acknowledged his debt to Schult's work in developing beta blockers and H2 antagonists. All those developments that Jim Black so successfully pursued really were rooted in the kind of analytical pharmacology that Schult had initiated. He also was the author of a textbook originally written by A.J. Clark called Applied Pharmacology and taken on through successive editions. Most of the later ones up to the 80s were co-authored by Heinz Schult. And that too was a really valuable and interesting textbook at the time. So he is the fourth of these, and the final one, again, interestingly, 3 of our 5 were refugees from Nazi Germany in the 30s. The final one is Martha Vogt, whom, again, many of us will remember in meetings of the British Pharmacological Society. She came from Berlin, spent a long time in the University of Edinburgh working with Gadam, among others, and was really particularly interested in catecholamines and catecholamine-mediated transmission, sympathins as they were known at that time. And it was largely the initiative of Martha Vogt to carry this from the peripheral sympathetic system into the central nervous system. So many of the seminal discoveries on the role of catecholamines in the central nervous system stem from Martha Vogt's contributions. So that is our list, and what I've failed to do, which because I'm too dozy, is to put up the photographs. There we have Bill Bowman, Derek Dunlop, Hans Kostelitz, Heinz Schult, and Martha Vogt. So that is our list, and I'm really happy that they have now been elected to our Hall of Fame. So that concludes that part of what I have to say. The rest of this evening's presentations will focus on the work of Tony Harmar. Tony Harmar was elected by the Society to the Vane Medal of the Society, which is given for contributions across the field of pharmacology. And Tony Harmar very sadly died early this year after a long illness. And the contribution that the Vane Medal is celebrating was his initiation of the database of drug targets, which was a project started by the International Union of Pharmacology, IUPHAR, who set up a committee called the Nomenclature Committee of IUPHAR, NCIUPHAR, which is a pretty boring title for an extremely important and valuable contribution to the subject. Now, what NCIUPHAR did was to realize that a nomenclature of all the different receptors, channels, drug targets, enzymes and so on was in a bit of a mess. Different pharmacologists were using different terminologies and probably describing different things. So NCIUPHAR was brought in to rationalize this, and I'm not sure whether the first chairman of NCIUPHAR, but certainly a very important chairman of NCIUPHAR recently is Michael Spedding, who worked closely with Tony Harmar in Edinburgh. And Tony's main contribution was to collate this big mass of rather complicated structured data into a searchable database. And there is now a database which owes its existence very substantially to the work of Tony Harmar, and is really an important and valuable resource for pharmacologists everywhere. And it's growing and growing and growing, and it's really sad that Tony Harmar is passed away and can't continue this, because it was really in full flood at the time that he died. So because he can't be here himself to deliver the Vane lecture, what we have done is to ask Michael Spedding, sitting in the front row here, to say something about Tony Harmar and his work, and also John Kelly, a long-time colleague and friend of Tony Harmar in the University of Edinburgh. And I think, are you going to start off, Mike? Okay, then fine. Well, thank you very much. So let's get on with the rest.
Thank you. It's quite a challenge, because my very first presentation to the Pharmacology Society in '72, Jim Black and John Vane were in the front row, and I can remember every single word of their question. We differentiate ATP and adenosine receptors, and now we've got Jeff Bernstock in the third row. So time has not changed that much in terms of issues, but John Vane obviously has been an absolutely major figure for British pharmacology, and the medal is therefore a very major issue in terms of who gets it. And my good friend and colleague for decades, Tony Harmar, has been awarded this. And today we would like to do a double act on the basis that John Kelly will cover effectively what are the early years of Tony, and then I will do a scientific issue to show you how scientifically he contributed markedly to receptor nomenclature, chronobiology, and the database, the implications and where it's going to go. So John will start off with some words about Tony as a man.
Tony was born in London in November 1951 and died earlier this year, aged 62. In November 2012, he was found to have a brain tumour. Despite of a considerable physical deficit, he continued his research until the beginning of this year, and was awarded an emeritus professorship shortly before his death. He remained engaged, controversial, and assertive until the end. In spite of his long-term interest in the Labour Party, he was determined to vote yes in the recent Scottish referendum. I suspect his greatest regret was the termination of his mentoring of classical and modern choral and instrumental music performed at a very high level by his family and friends. He was an accomplished pianist and sang with the Edinburgh Singers, where he met his wife, Gillian. He also founded and sang with Cadenza, which grew from a small chamber choir to become one of Scotland's most exciting mixed-voice choirs. Latterly, he sang in the Edinburgh University Renaissance Singers. He leaves behind his wife, Gillian, and two sons, Thomas and William. I first met Tony in the early 1970s when we shared adjacent space at the top floor of the Pharmacology building on the new hospital site in Cambridge. We were both, in effect, outcasts from Leslie Iverson's newly formed MRC unit. Everybody else on the unit was housed on the floor below and worked flat out on dopamine binding sites or cyclic AMP. Dopamine had just been identified as a chemical in the brain most likely to be linked to the behavior of patients with schizophrenia. Tony had drawn the short straw and was working on octopamine. A common thread in the unit was the use of radioactive labels, and thus highly dependent on scintillation counting. The output of the counters took the form of paper printouts, like telephone directories, followed by the use of handheld calculators. With Tony's help, I set about writing a suite of computer programs to read in paper tape and calculate the results in picomoles of bound substrate. Our common interest in the trivia of octal arithmetic and ASCII code led to a long-term friendship, with both of us continuing to use science and other pocket computers long after everybody had a PC on their desk. Laterally, in the early 2000s, we worked together on transgenic mice unable to stick to their allotted circadian rhythm. Tony was educated at St Paul's School, London, and in Cambridge studied biochemistry and completed his PhD in the MRC Neurochemical Pharmacology unit under Les Iverson. After 2 years, it became clear that the amount of octopamine in the mammalian brain was infinitesimal, and he switched to characterizing octopamine receptors in cockroach brains. On graduating, Tony was shipped off to work with Erwin Levitan, another of the Boston Mafia, in the Friedrich Miescher Institute in Basel. Although this should have proved a stimulating place to work, Tony wrote, "This postdoc gave me the chance to consolidate my knowledge of French and German and to learn to ski." No longer attracted by snails, Tony moved to Bristol and spent 2 exceptional years with Peter Keen looking at the biosynthesis of substance P in dorsal root ganglion cells. Good timing, as substance P had just been identified as a unique marker of nerves carrying the activity perceived centrally as pain. The subsequent papers, including a Nature paper, were well received, and Tony felt it was time to find a permanent job. In 1981, Tony joined the MRC Brain Metabolism Unit in Edinburgh, which was widening its remit under the new director, George Fink. The availability of post-mortem brain tissue led to an expansion of Tony's work. An invitation to look at a human laryngeal carcinoid tumor containing a high concentration of substance P led to the isolation of the cDNA encoding the human substance P precursor. This taste of molecular biology led to Tony changing his approach and focusing on the isolation of the genes for the receptors involved in the action of a number of peptides, in particular vasoactive intestinal peptide, VIP. Using mice lacking the VIP receptor, Tony was able to show this receptor to be essential for robust circadian rhythm. In 2001, the MRC Brain Metabolism Unit closed and Tony transferred to Edinburgh University. He was elected a Fellow of the Royal Society of Edinburgh in 1996 and appointed to a personal chair in 2006. As a biochemist, Tony had always been interested in the databases developed by the Nomenclature Committee of the International Union of Biochemistry and Molecular Biology, and felt strongly that the British Pharmacological Society should push for a similar database describing the pharmacological, chemical, genetic, and anatomical information on the proteins which are the major targets of drugs. Thus, latterly, his foremost interest became the development, funding, and curation of such a database. Thank you. Thanks.
Thank you, John. I'd now just like to present the scientific work that Tony's been awarded the prize for. I would also like to say that I hope this goes well because he's a great friend of mine, he's a great guy, and it's quite awe-inspiring to present somebody else's work posthumously, at the same time getting the right balance. And what I'd like to do is celebrate Tony's work because I think he was a guy who really showed what pharmacology could do, and in many different ways. And here is one of the meetings of the NCI-UFAR group, which meets twice a year, has done for the last 25 years. Paul Van Houten was the very first president of that, the chairman of this, and I've been secretary and general and chairman for ages. But a very distinguished group of people will fly, such as Bill Cattrall, who was one of the major people in voltage gate ion channels, will fly coach to work for a weekend in a cellar in either Paris or Edinburgh, right, and then fly back just for the pleasure of working for NCI-UFAR. So it is something which is quite amazing scientifically and also humanly. And Tony was here and surrounded by the people in the database group. Now, he didn't get to be appointed to NCI-UFAR by starting a database. You've got to, first of all, do some quite amazing work. As chairman of NCI-UFAR, I'm a sort of scientific groupie whereby I can go around the world and try to entice people who are real experts to be able to contribute to their field. And Tony had effectively done that by effectively being the major scientist working on family B, or class 2 now, G protein coupled receptors, in terms of cloning them and being able to then express their function. Substance P you've already heard about. And actually, it was just to show you, this was the primitive period of molecular biology. So we had 10,000 clones in 96 well plates, transferred onto filter paper with 10,000 cocktail sticks. He used the entire amount of cocktail sticks in Edinburgh in these experiments. Then later, he'd already previously set a world record in terms of analysis of cockroach brains, but now, effectively, most of these receptors had been cloned in their function defined by his group at a time when molecular biology was less high throughput and when there were only 6 million database pairs in GenBank. One of the key things that he's shown is the key issues of circadian rhythm of biological parameters and what the drivers are. And there we're interested because Servier and I've been involved in the development of melatonin agonists for resynchronizing biology. And it's a major drug which has come out of this. And part of this is the fact that light can stimulate the suprachiasmatic nucleus, which then can transmit a variety of signals throughout the brain, and also the pineal gland, giving a peak of melatonin. And this has led to work on new antidepressant mechanisms. What Tony showed was quite clearly the molecular aspects which were involved in the chronobiology, particularly in the suprachiasmatic nucleus. And early on, he'd been able to develop the molecular tools to be able to analyze that. And it's very significant and important work showing that the mammalian suprachiasmatic nucleus is the master circadian pacemaker, getting input from light. And he's been able to define with his molecular tools that he built up that this affects chronobiological rhythms. This is the rhythm in terms of which is then destroyed in the presence of vasoactive intestine peptide knockout mice, and also for the receptor or for the peptide. And also to modify this with antagonists to the system. And this work was key to understanding how the chronobiological systems were organized. And so, just to show you at this time how work proceeded, he telephoned up to Mick Hastings, who drove up with his biological wheels to Edinburgh, set up the experiments to look at the mice that Tony had developed. And quite clearly, you can see here the suprachiasmatic nucleus with the receptor classed as VPAC2, which is the nomenclature which Tony was involved in defining in the subcommittees, and also associated with this also are the clock genes PER2 and PER2. He also started off by being able to, for the PACAP receptor, pituitary adenosine cyclase activating peptide, to be able to do the classic molecular biology of the time, splicing up the receptor and looking at what was the high affinity values for the receptors and being able to work out their function. And also that the human PAC1 receptor led to dose-dependent hydrocephalus and many other functions. He did also some really beautiful work, and this is really very elegant indeed, in terms of looking at the projection zones from the SCN throughout the brain to the paraventricular nucleus and defining how this clock signal then goes out to the rest of the brain to integrate our circadian rhythms, which, as I said, Servier subsequently exploited in terms of being able to make the only new antidepressant to come out in the last 5 to 10 years. So it really is very important work. He was able to overexpress the receptor in the SCN to alter the circadian phenotype. And this is a landmark Cell paper whereby showing that it was absolutely essential for circadian function in the mouse suprachiasmatic nucleus, because, as you can see, knockout mice in terms of the clock gene M-pair have got no circadian rhythm, and also for BMAL, and this is associated with AVP production and the clock gene production. So this means this was conclusive proof of this very important mechanism in terms of how we will actually be able to go to sleep tonight or be able to continue to be able to function. He also showed that what the receptor did in the rest of the body, and this is one of the areas where I was able to indirectly work with him, because we were working with a guy called Pierre Gressens in Paris, which we were able to put together some work with Pierre and Tony, whereby vasoactive intestinal peptide has got very marked, this is a lesion in the white matter of P5 newborn mice. You can see a marked lesion, which mimics leukomalacia, a major problem in excitotoxicity in the newborn. And vasoactive intestinal peptide at 1 microgram injected locally has got very marked protective effects. And we were able to work out the second messengers associated with this. Another aspect which we was able to do is to work out what was important in terms of feeding and what was important in terms of light. That's a really crucial issue, and finding that PACAP and VIP have got different roles, and that the time feeding of mice modulates light and trains circadian rhythms. And some of these effects can be knocked out by PAC, by PACAP receptors, but the VIP is absolutely crucial to all of them. He was then able to produce a model for the peptidergic signal and the control of circadian rhythms, which I won't go into, because I've got quite a lot of other things to talk about tonight. But one of the our regrets between the pair of us was that IUPHAR is gearing up to look at immunopharmacology in a big way, and that we were both of us very interested in the immune-circadian interactions. And that is something which I'm afraid Tony was not able to follow up on, but we would like to be able to go on to follow up. So then, he'd been working in the committee for a few years, and we needed to produce a database. So we took the decision then of being able to look at the European Bioinformatics Institute, which has got the biggest bioinformatics institute in the world, who proposed they would make a contract with them to set up this database. They actually, as bioinformaticians, made it too complicated. So Tony took it back, set up a simple MySQL database in his labs, and therefore he's now, this is the organization of NCAUFAR, where I'm now chair, and he was head of the database. And this is the database group, which he's grown up completely himself with Chris Southern, who is also our chemical database officer. And I just want to point out that Tony was a most remarkable man. He said, just get on with it. So even when he was sick in the last 18 months, we were able to work out a succession plan with Jamie Davis in Edinburgh, who's taken on the group, and therefore there's a almost seamless interface in terms of the way it's been developed. And NCAUFAR meetings are twice a year, spring and autumn in Edinburgh and Paris, attended by all the core committees and attended guests, and members are welcome. And also, we've been able to organize this and get in some important scientists, including some young blades like Anthony Davenport, who's here today in terms of involving pharmacology. And we have also corresponding members which play important roles, especially as corresponding members correspond, and therefore it's free, so we don't have to pay for them. But we thereby be able to get people to come in, and I would point out that as an audience, you look very much like suitable victims for some more work. One of the key issues also is that and this is something we worked with Tony about in terms of developing, that we've got many subcommittees. We actually have 80 subcommittees of currently, it's actually 672 scientists working in a coordinated way. Now it's Adam Pawson in Tony's group who does the day-to-day contact. But this is a unique social and human organization which works only on a feed-forward mechanism. That is, major scientists are asked to join to be a subcommittee member. They can then tidy up their own area by making recommendations and checking that what goes into the database is correct. What is more, they get good citations, and that means that their students or postdocs can also get good citations. So that gives two powerful levers in order to be able to get people to join this activity. And so some of the achievements that we've done is with Tony. We've also set up and thanks to a major grant, I can't underline enough how much the BPS has been able to help the Guide to Pharmacology, and by joining forces with the scientists, as you'll see later, involved the guide and receptor and channels with the IUFAR database. This gives a really powerful aspect, allowing these major experts to be able to be to have their propositions published with high impact. And obviously, sometimes the human scientific aspects can lead to real controversy, which I won't have too much time to go into. But we can certainly discuss a few of those. And actually, if you can actually do an H-index for NCAUFAR, and it's 72. And that includes some very major issues which seamlessly went from recommendations in Pharmacological Reviews or the British Journal into the database. And we entirely rationalized the voltage gate ion channels, ligand gate ion channels. And also there's the things that we've stopped because there was a potential tsunami of spurious GPCR heterodimers, which Tony was very well aware of because of his own work, caused by overexpression in artificial systems. And we put in high criteria which stopped people being able to claim that this was a heterodimer just because you've overexpressed it, unless you showed it was an in vivo possibility. And I'm just going to show you briefly a couple of examples of how this works. So this is Tony and Bill Cattrall, who then, and I'm delighted with Theo Godfrey in the room, because there we have now all of the gene products which are voltage-gated ion channels, which were classified and with multiple subcommittees led by Bill, who then, with Tony's group, put them into the database, and therefore you can interrogate any of those channels and find the main ligands for those channels in the database. And obviously we also have some of the structures available, and it's quite amazing how now we can look to see how they relate in structure and link up with PHARMA, etc. So you can have the recommended structures in the database. It's an area we're going to develop further. One issue, which I think is a non-controversy, which is quite nice, is that the committee is open to academic and industrial scientists. And because we only work on validated pre-competitive data, whereby something has got to be published and then validated, that actually means that we're working on a slightly laid-back level. We're not quite at the very front, but it means that those controversies are reduced. And the industrialists, therefore, can work on what's going to happen. And I'm going to show you how that works in a minute. I'd also point out just how effective what we've built up and what Tony's built up in terms of its classification. I'd like to point out the remarkable effort done by Steve Alexander in terms of getting the transporters in. And Doriano Fabro from Novartis has got all of the kinases classified with the genomic information, extensive links to external databases, the affinity data for 72 kinase inhibitors across 546 kinases. It's all there in the database. You've just got to look. And what we also try and do is have the database, and also you've got an article coming out in BJP, 10 things that a pharmacologist must know about kinases, allosteric mechanisms, all of the issues which are crucial in terms of modern structure activity with the structures. So that I think is very important. And just to point out that Alina Fascienda, who was recruited by Tony, this shows if you go into the database, you can get compound selectivity for all of the kinases for a whole series of compounds. Right? So it's an open-ended system. It's just a matter of getting the experts to put the data in, getting the money to have the curators, and it's a feed-forward system which is beneficial in terms of humanity. So we've also produced recommendations for allosterism with Arthur Christopoulos, and these across all target classes. So that's published, has just come out in the and I'd like to go over another serious issue, which is that this database is freely available, so it's readily looked at by industry. At the same time, we as an industry and we as a science have to recognize the fact that there's been a roadblock and that there's been a major loss in sales to generics because we haven't been able to produce enough drugs for difficult diseases. And Jeff Cummings said the failure rate in Alzheimer's is 99.6%. And biological products are expected to account for more than 50% of sales. Yet, Sir James Black and John Vane produced drugs years ago when we didn't know many of these issues. Why is that? Well, I think IUFAR and the database can is addressing some of those issues, and I'll explain why. There is a coffee downstairs on the mechanisms involved in schizophrenia. So we've worked on schizophrenia, and this is a paper that I put together on potential mechanisms in schizophrenia, obviously which aren't fully accepted. But if you're an industrial scientist, then if you're just choosing one of these, you've got 19. Obviously, the odds are stacked against you getting a compound through to phase 3. It's one of the reasons why people are leaving the CNS. But for all of these receptors, as pharmacologists, we also know that the variables involved in any one of these receptors are enormous in terms of the functional effects which can come out. And when you look at those variables, many of these are classical pharmacology. But the total number of variables, when you add on to the total number of mechanisms, means that the chance of getting drugs out is low. And when you consider that that experiment that you're doing is one of the most expensive experiments of getting a drug from zero to, say, proof of concept, it's equivalent in aerospatial research. And why? Because all of these variables can change the output. And one of the things that I think that with IUFAR and with the database we're able to show is that the immense growth of knowledge is accompanied by the same time an immense growth in variables. So we don't control any better a drug that we put into people than we did 40 years ago. We know more about it, but controlling all those variables in the right space is not necessarily so easy. And this is something, Tony and I had a lot of discussions about this, and it's one of the things we want to do, and I think that one of the reasons that Shilton Black so many years ago used null methods to cancel out these variables. And also Vane used bioassay in pathological conditions, whereby you don't need to reconstruct all the receptors with all the signaling proteins to get it right, and then screen. And then by screening in a pathological situation, you can then get out compounds which are not the same as you would find in HTS. And that is something that my professional life has shown me quite clearly. And I think is a thing which also allows really innovative pharmacology, old pharmacology. So one of the issues that IUPHAR is doing, and Tony set this up and we're doing it for the database, is doing recommendations for the variables which will affect the new science which is coming in, which has got to be worked through by pharmacologists in drug screening. And those are allostery in press as how you can define that. Alternative splicing, we've already put out recommendations for that. Receptor polymorphism, we're trying to get a database. We've got an article on all of the major epigenetic drug targets in press, and we're looking at non-coding RNAs. And we would like to do this. At the present moment, thanks to Tony, Anthony Davenport, and I'm on this as well, Wellcome Grant, we've got a significant budget, and what we want to do is to be able to continue Tony's database as a guide to pharmacology from the IUPHAR and BPS, which is then a worldwide resource, which it already is to a certain extent, and to extend this, to become a one-stop source of pharmacological information on drug targets, substance act on them, and also, with accompanying articles, do the limitations, the pharmacology, to put pharmacology right back in the center of drug discovery. So I think it's a very major goal, and Tony's database people, I think, have been a credit. And I would just like to say that I'd like to just bring a couple of issues up about Tony now. Tony was also a person who had great technological expertise and great interest in computing and novel solutions. He was a great go-for-it guy. And as you know, when you've got people who are sick, it's quite difficult to talk to them, you might imagine. Tony and I Tony can be truculent at times. We only had one major falling out, and that was October 2 years ago at the IUPHAR meeting, where we both went out hammer and tongs, and it upset both of us. And I didn't realize what was happening, and a month later he was diagnosed with a glioblastoma. Effectively, from then, IUPHAR has been run by weekly telephone calls between Tony and myself, and Steve Watson also can be there, as you can remember these heroic days. And effectively now we're working out with the BPS how to substitute for that. But I was able to telephone Tony for the last 18 months of his life every week with joy, because he was always positive, he was always thinking of new things. The only trouble is that I now have to ensure that some of his ideas still go ahead. He developed computer programs for, as he lost mobility, to run his bed, get it lifting up, and those technological aspects were a really great joy to him and really novel as well. And so we've just got to carry it through with that. The other thing that I enjoyed about him was that he was always positive, unless you were being stupid, and he was also had very fixed views and many different talents. One of his talents was language. And also, he had a blistering sense of humor. And one of the things that, therefore, his last real joke, which I still don't know how serious it is, was that I'd managed to do something which is quite remarkable on the basis that I could find myself an artistic niche. Because, surprisingly, I've been able to publish poems on athletics in French, which have been actually published at a very high level in France. I don't know how it did. They all fell out of my brain. And obviously this is a slightly niche market, but I actually have a contract from a major French poetry publishing house, a serious one, to write a book of poems, the next second book, with films for the next Olympic Games in Brazil. And Tony, being a linguist, actually said he liked them. And therefore he gave me, with his typical sense of humour, something which I don't know. This is one of them. It's called The Last Lap, which relates how my boss, a Scotsman, put our research group in a French visit into a house, into an old people's home, because it was cheap. And I came out down the long corridors, which were 400 metres long, which were tiled, just made to break these old ladies' hips. An old lady came out from the door. I came out and said, "Good day." I ran down the floor. I went out, the beautiful night. I ran 8 kilometres and came back, and the old lady was on a stick at the end of having done her 400 metres. Okay? Now, I don't know which was the best athletic performance. Hers or mine would have been at the same VO2 max in order to be able to do that. And then my mother did it, and then we did. Then eventually it's going to happen to me. J'attends mon tour sur le ruban bouclé à l'infini. I wait for my turn on the ruban bouclé, which is a track, because it's a track, it goes on to infinity. And Tony asked me to read that in French as the last issue in his funeral service. And I still don't know whether he really appreciated it or it was his last joke on me. Because that was the guy. So I've spoken to Gillian about it, whether I can say this, but yes. So I can see whether I can play a last joke on Tony. Because Tony was, as I said, a stout, despite the fact he was English, was stoutly for independence. He was also a humanist, and he was also somebody who was very much against standard religion. So I've spoken to the database people and to Gillian, his wife. So I think what we can do is, as my last joke on him, is to declare him the patron saint of the IUFAR database. And to a certain extent, he already is. Because frequently, if I propose anything, everybody would say, well, what would Tony have said? So he is. So for my good friend, I'd now like to turn it round and say that he was a great scientist and a great person. And Shankly said football was greater than life or death. Well, frankly, I think that's a fairly silly thing to say. But pharmacology, in this case, he's made something, it's continuing, he's already been able to ensure its continuance. This is one of the reasons why I started off, on nomenclature, right? Because Max Wheatman and I produced a first rather rubbishy antagonist of ATP. We published that identification of separate receptors for adenosine and ATP in 1976. Okay, so you can see the young scientist there. And then Jeff produced almost the same work, but called them P1 and P2. As a result of which, he gets thousands of references to our few. And the same with it's privilege. And what's happened, sometimes you've got to wait, because we wait for the cloned receptors. And now we know there are all these ATP receptors. Now, what you've got to think about in the variables which we've proposed is not what you're listening to now, but in terms of the epigenetics, in terms of those other targets, what are people going to be saying in 30 years? And when they screen their drugs, right, for major targets, what do they not know? And it helps if you know what not to know and how to screen them. And that I think, is one of the main things for pharmacology in the future. And I think it's one of the things that we've learned early on, and that nomenclature sometimes can be useful, but particularly if it's linked up to mechanisms. I think you probably discuss it better over a beer, but I'll hand the chair back to
You won't get the questions, Matt. You won't get them. Well, that concludes this evening's presentations. I'd like to thank particularly John and Michael. I think they've presented us with such a clear picture of Tony Harmar, the man and the scientist, and actually the visionary, because the plan to develop this database was certainly a bold initiative that he took on along with other people in our UFAR to make this thing work. I think a lot of us, I would say I was quite skeptical about as to whether you could really take all this pharmacological data and systematize it usefully in this way. But I think the way that this database has developed and grown and become useful shows that the original visionaries were dead right in their anticipation of what could be done. And I think Mike has shown us that the task is really, it'll never be finished. Clearly, as we learn more and more about the molecular details of how ligands interact with their targets, we're going to get more and more complication, not just the dozen or so complicating factors that you raised, but they're going to keep growing. And I think a database like this is going to become an absolutely central resource for pharmacology in the future. And I think we can really take pride in what has been achieved by one of our members, Tony Harmar, in getting this going. And he's not only got it going, but he's got it going in a way that after his demise, the project still has plenty of legs and plenty of life and will carry on in his absence. So that's a really creditable achievement, and I think we can all take pride in what has been done. So I think that concludes the proceedings for this evening. There's a reception laid on out there, so you can all schmooze away to your heart's content until 10 o'clock this evening. Thank you very much.